Hi again. This lecture is the second part of the topic of power converters and their important role in the integration of renewable distributed generation. If you haven't seen the previous lecture, I recommend you do so. First, during the last lecture, you were able to understand the basic principles of how a rectifier works for the conversion from AC to DC. We will start this lecture by understanding the principles of how an inverter works for the conversion from direct to alternating current. Power converters can contain uncontrollable semiconductor devices like the diode or controllable semiconductor devices like transistors and MOSFETs, which can be used as switches. Let's assume that S1 and S2 in the figure are controllable switches. Let's consider that the circuit shown has a constant DC voltage at the input. If S1 is on and S2 is off, the circuit will conduct through the highlighted path. In this case, the magnitude and direction of the output voltage is equal to the magnitude and direction of the input voltage. This corresponds to time periods 1 and 3 in the figure. If on the other hand S2 and S1, S2 is on and S1 is off, the circuit will conduct through the highlighted path. The magnitude of the output voltage is equal to the magnitude of the input voltage, but the direction is opposite. This corresponds to time period 2 in the signal. When we look at the final output, we can see that the signal has a positive and a negative part, and that is periodic. Even though this is far from a perfect sinusoidal wave, it resembles it. As I mentioned during the previous lecture, the topology of the circuit inside the power converter will define how close the signal will look to the idea, in this case, a perfect sine wave. By using more semiconductor devices in more complex topologies, it is possible to obtain better outputs. Inverters are necessary when we want to connect a DC generation unit, such as a photovoltaic panel, to the AC distribution network. Without these power converters, the connection to the grid wouldn't be possible. Other distributed generation units that require an inverter for their connection are fuel cells and batteries, among others. The role of power electronic converters is not limited to aiding these AC to DC or DC to AC conversions, but it is broader than that. Power converters also allow to adjust the output voltage level so that a load can be connected. For example, a DC-DC converter is used to increase or decrease the output voltage with respect to the input voltage. A DC-DC converter is analogous to the AC transformers that we discussed in our first lecture. Just like in the case of AC, transmission losses can be reduced when power is transmitted at higher voltage. A high voltage DC transmission between a large offshore wind park and the respective substation is therefore beneficial. The voltage can be increased and decreased using DC-DC converters. A DC-DC converter uses transistors as switching elements. Let's have a look at that circuit. It will help you understand the basic operation of a DC-DC converter. The transistor switches on and off, and as a consequence, the output voltage is conformed of rectangular blocks. The average output voltage will be V average equals T on over the period times the input voltage, where T on is the on time of the transistor. The ratio between the time when the switch is on and the complete period is called duty cycle. The average output voltage is proportional to the duty cycle and can be deduced from the equation. A DC-DC converter can be used not only in the case of increasing or decreasing voltage for high voltage transmission, but for many other applications. For example, it can be used to control the speed of a DC motor, for which a DC supply is available. The last type of converters is the AC-AC power converter. The converter is used to convert an AC waveform into another AC waveform at a different voltage level and or frequency without any intermediate DC conversion. The principle of operation of this converter is outside the scope of this course, but it was worth mentioning its purpose. Power converter devices are crucial elements for the integration of renewable sources, both at large scale and at a small scale. In the exercises, you will be able to play with the duty cycle and adjust the output voltage of DC-DC converter.